Welcome to the Unit 14 Section 2 video on compound inequalities. The solution to an inequality is the set of all values that make the inequality true. We can represent solutions to inequalities in several ways. We can use set notation, which would be read as the set of all x such that x is less than or equal to 6. We can use a number line where we use either an open or closed dot and shade either to the left or right. Included values use a closed dot on the number line. Non-included values use an open dot on the number line. And in interval notation, we can express this using brackets for included values and parentheses for non-included values and infinity. To solve a simple inequality, where possible, combine like terms first, isolate the variable to one side of the inequality, and remember to reverse the sign of the inequality if you multiply or divide each side by a negative. So let's solve this inequality expressing the solution on a number line in set notation and in interval notation. So first we're going to subtract 10 from each side, and then we're going to divide by -6. Since we're dividing by a negative, we will flip the inequality, and we end up with x is greater than 2. So in set notation, we write it as the set of all x, such as x is greater than 2. In a number line, we are going to do an open dot on the 2 because there's no equals to, and we'll shade to the right since we're greater than. And in interval notation, we'll indicate the interval from 2 to infinity, where we do not include the 2 since we do not have an equals to. In this inequality, first what we're going to do is we are going to take our x term, 3x, and subtract it from each side. Then we're going to subtract 3 from each side. Then we will divide by 5 to give us -2 is greater than or equal to x, which can be written in set notation as the set of all x such that x is less than or equal to -2. On a number line, we are going to use a closed dot at -2 and shade to the left. And in interval notation, we'll indicate -infinity to 2, where we use a bracket to include the 2. A compound inequality is a sentence with two simple inequality statements joined together. So in an AND statement, it consists of all numbers that satisfy both simple inequalities. It is an intersection of the solution sets. So in a Venn diagram, the intersection of A and B would be the area that A and B overlap in. That is indicated by the shaded region. That is your intersection. In an OR statement, it consists of all numbers that satisfy at least one of the simple inequalities. It is the union of the solution sets. So in a Venn diagram, it would include every part of A as well as every part of B, including the parts that are shared. So the union here is shaded. So the way I look at it is an AND statement has to satisfy both things. An OR statement satisfies everything from both statements. So we're going to look at what's shared or everything. An AND statement is what's shared, an OR statement is everything. And you're going to see that in the following examples. So in this example, we're going to express x is greater than 2 and x is less than or equal to 5 on a number line in set notation and in interval notation. So we're going to start with a number line that we're going to sketch out just so we can work with it a little bit. We're going to take our x is greater than 2 and we're going to shade that above the number line. And we'll take x is less than or equal to 5 and we'll sketch that above the number line. Since this is an AND statement, it's got to be the part that is shared. So the part that is shared between our two solutions is the area where we have overlap. And that would be from 2 to 5. And you cannot include the 2. So how do we notate this? In set notation, you're going to indicate it as the set of all x such that 2 is less than x, which is less than or equal to 5. x is all the values in between and including 5. On a number line, you're going to take the part that overlaps and you're going to shade just that part. We'll use an open dot on the 2 because it's not part of the solution for x is greater than 2. And we'll close in the 5 because that solution is shared. And then for interval notation, it is, now that we have the number line, easy to write as the set of 2 to 5. The interval from 2 to 5, including the 5, so we use a bracket on the 5. Let's express this solution on a number line. So again, we use our sketched out number line. We're going to sketch the solutions above it. X is greater than 4 and x is less than -1. Now here we have an OR statement, which indicates that we need to include every part of the solution from both lines. So in this case, in set notation, we are going to write the set of all x such that x is greater than 4 or x is less than -1. On the number line, you're basically going to take all the parts that are shaded in either and shade all of it on the number line. So you have two sections that are going to be in the interval. You have -infinity to -1, union with 4 to infinity. In this one, we have an AND statement. So we are going to take our number line, we'll sketch the two inequalities above it, and since this is an AND statement, we want the part that is shared. So the part that is shared is the part that is represented by x is less than 3. So since x is less than 3 takes care of everything that is shared on its own, we're going to write in set notation the set of all x such that x is less than 3. On the number line, we will just indicate x is less than 3 and an interval notation from -infinity to 3. In this example, we are going to express this OR statement. So we are going to sketch out the two individual inequalities. And since this is an OR statement, we want every part of it. So x is greater than or equal to 0 will take care of all parts because x is greater than or equal to 4 overlaps x is greater than or equal to 0. So x is greater than or equal to 0 will include all of our solutions, including those from x is greater than or equal to 4. So in set notation, the set of all x such that x is greater than or equal to 0. On our number line, we'll indicate that single inequality, and in interval notation, the interval from 0 to infinity with a bracket including the 0. Let's express this compound inequality on a number line in set notation and in interval notation. So let's sketch out the two inequalities first. Now, since this is an AND statement, we want what's shared. Well, if we look at these two individual inequalities, there's nothing shared between them. So that means there is no solution. So we'll indicate that using the empty set, which you can indicate by two brackets with nothing in them, or by a 0 with a slash through it. On the number line, you would just leave it alone. You would not put anything on the number line because there is no solution. And in interval notation, you would just simply say none or no solutions. Now for this OR statement, we have our two individual inequalities. And if we take everything that is included from both, you'll notice that we have overlap, but if we were to include every part of these solutions, it would encompass the entire number line. So our set notation would be all solutions, indicated by our double bar R, all real numbers. Our number line, we would shade the entire number line. And in interval notation, it would be -infinity to +infinity. To solve a compound inequality, simplify each part of the compound inequality and then find the intersection or union. To solve a compound inequality written as a single statement, you can separate the inequality into two individual statements with and solve as you would for a simple inequality, or you can leave the inequality as a single statement and isolate the variable by using inverse operations on both sides of both inequalities. Now, keep in mind, you can only solve a compound inequality written as a single statement if it's an and statement, or statement inequalities cannot be indicated by a single inequality. They have to be two separate inequalities separated by or. So let's go ahead and take a look at our first example that is going to show you how to handle a compound inequality that is an and statement that's written as one statement. So we're going to express this solution, but first we have to find the solution. So we're going to take our inequality and we're going to isolate the x in the middle part. So the first thing we're going to do is add 8 to all three parts. So negative 11 plus 8 gives us negative 3 on the left. Negative 2 plus 8 gives us 6 on the right. We're left with negative 3x in the middle. And then we're going to divide everything by negative 3, which flips our inequalities. So we have 1 is greater than x, which is greater than or equal to negative 2. So if this is done correctly, x should fall between the values on either side. So in set notation, we're going to indicate this as the set of all x such that negative 2 is less than or equal to x, which is less than 1. On our number line is going to be the values from negative 2 to 1, not including 1. And in interval notation, negative 2 to 1 with a bracket indicating we include the negative 2. Let's solve this single statement compound inequality. This time, let's do it by separating it out. So what you're going to do is take the first part, x plus 10 is less than 2x minus 8. And you're going to take the second part, 2x minus 8 is less than or equal to 8 plus 3x. And you're going to create two statements out of it with an and in between. Now let's solve the first inequality by subtracting x from each side and then adding 8 to each side to get 18 is less than x, or x is greater than 18. On the other inequality, we're going to start by subtracting 2x from each side and then subtracting 8 from each side, which gives us x is greater than or equal to negative 16. And we're going to stick our and in between. Now in set notation, we can indicate this as x is greater than 18, because remember, we're doing the part that's shared, and since x is greater than 18 is shared with x is greater than or equal to negative 16, x is greater than 18 will take care of every part that's shared between the two. On a number line, this will be indicated by an open dot at 18 and shaded to the right, and an interval notation, the interval from 18 to infinity. Now, for this compound inequality, we have an or statement. So we're just going to set it up with our or in between. We're going to solve each inequality separately from each other. So we get x is less than or equal to negative 7 for the first. We're going to get x is greater than 9 for the other. And then we are going to stick our or in between. And we're going to take that last statement that we have, and we're going to just drop that into set notation as our solution for that part. On the number line, we have everything shaded, so everything that is less than or equal to negative 7, and we'll also shade everything that is greater than 9. And in interval notation, we have two intervals that are going to be joined by a union. For this compound inequality, again, we have an or statement, so we will set it up with our two separate inequalities. We are going to solve each inequality separate from one another, stick our or in between on that last statement, and then take that last statement and drop it into set notation. Now, if we drop it into set notation, we have some redundancy here because we want to include everything between the two inequalities. Well, x is less than 3 includes the entirety of x is less than or equal to negative 1. So we don't need the first statement. We only need the second statement to give us our set notation solution. And on a number line, that's going to be everything that's less than 3. So we'll shade everything left of 3. with an open dot at 3 since we do not have an equals to, and an interval notation negative infinity to 3. Now let's go back to an AND statement. Here we have two inequalities joined by an AND. So we are going to go ahead and solve these independently of one another because we can't write it together because there's not a common section to link in the middle. So we'll go ahead and solve these independently. We'll solve the one on the left, and we'll get x is less than 0. We'll solve the one on right, and we'll get x is greater than or equal to 2. And this being an AND statement, we want to do what's shared. Well, between x is less than 0 and x is greater than or equal to 2, there is no part that is shared between those two. So we have the empty set as our set notation. We have nothing shaded on our number line, and our interval would be none or no solutions. For this OR statement, we're going to solve each side independently. We get x is greater than or equal to negative 3, or x is less than 3. And we want to do everything. Well, if x is greater than negative 3, and we have a part that has x is less than 3, everything is going to be part of the solution. So we have all real numbers as our set. We have everything shaded on our number line, and our interval would be negative infinity to positive infinity. Now let's do an application. The radio station in Winchester sends out signals for a radius of 100 miles. The Thiesville radio station sends out signals for a radius of 60 miles. You are driving from Winchester to Thiesville, a distance of 200 miles. Write an inequality that represents your location while you can listen to one of the radio stations on your car radio. So let's let D be the distance you have traveled from Winchester. Winchester can be heard up to 100 miles away, so you can listen to that station for the first 100 miles of your trip. The station in Thiesville can be heard up to 60 miles away, so you can listen to it when you get to within 60 miles of Thiesville. So when you're listening to the Winchester station, your distance from Winchester is less than or equal to 100. Now for the Thiesville station, you have your distance greater than or equal to 200 minus 60. Because Thiesville is 200 miles away, you subtract the 60 miles before Thiesville that you can start listening to the radio station, and you have a distance that is greater than or equal to 140. So your solution set would be the set of all distances, such as your distance is less than or equal to 100 miles from Winchester, or your distance is greater than or equal to 140 miles from Winchester. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.